This video we're going to insert a node at the end of the linked list. And as you remember, there are three basic cases when we try to insert a node on the linked list. We either insert at the front of the list, we insert in the list trying to preserve the order, or we can insert a node at the end of the list. So in this video we're going to talk about this last case, which is inserting a node at the back of the list. So if you remember, a typical linked list, basic linked list, consists of a series of nodes that are connected to each other by means of a reference that refer to the node that is after, and we call that next. There is an external reference called front, sometimes also called head, and that reference let us know the location of the very first node in the linked list, and the last node on the last list has its reference set to null. So we know where the list begins and we can figure out when the list finishes. In this video we're going to try to insert a node at the end of the list. That node will have its own reference, okay, because we create a node and we call a reference, for example, new node, and that's precisely the node that we want to insert. So this node will have a value, will have a next field that is set to null because it's not connected to anything else, and it will have a reference that let us know where the new node is going to be. In this video we are going to discuss a very simple technique to insert this node at the end of the list. So basically what we have to do is to change the value of this reference, which is currently set to null, to refer to the same thing that new node refers to. And notice that when we do that, there is nothing else that we have to do, because then this new node becomes the last node and its reference is already set to null. Inserting a node at the end of the list has basically two cases. The case which we always need to cover when we deal with linked lists is when the list is empty, and that's the trivial case. So if the list is empty, what happens? The reference that is called head or front that let us know where the first node is has value null because there is no node in the list. The list is empty. So the value of head, as you can see here, is null, or the value of front is null. And then we have a new node that has a value and has a reference, and we want to insert this node into the existing list. But because the list is empty, all we have to do is to change the value of this reference from being null to refer to the node that we want to insert, and then we need to make the reference in that node to be null. So head refers to the first node. This node is not only the first one, but it's also the last one because it's the only node on the list. So the next reference of that node has to be set to null. That indicates that that node is the last one. So it's a very simple case. The other case will be when the list is not empty. It doesn't matter how many nodes we have on the list, at least we have one node. Here we have a picture where there are 4 nodes, and again, it's a very basic linked list. We have a reference to the first node that is called head. Every node refers to a node using a reference called next, and the very last node, which is the one with value p, has a reference that currently is set to null. How do we insert a new node at the end of this list? Well, we have to find the end of the list. And to find the end of the list, we're going to use an external reference called temp. And we traverse the list starting with the first node, and we're going to traverse the list until we find the last one. And again, we find the last one because that is a node that has the next reference set to null. When we find that node, what we need to do then is reconnect, okay? Reassign that reference that currently is null to refer to the new node, which in this case is S, as I explained before. Okay, S has its own next reference set to null. At the end we have the last node, which is now is S with a reference to null that indicates this is the last node, and head hasn't changed because we didn't modify the beginning of the list. Let's take a look at the code. And the code is very simple, and it has an if-else, and if-else because we have two cases, when the list is empty and when the list is not. To check for empty list, we check the value of head. If head is null, like this picture here indicates, that means that the list is empty. Very simple case. All we have to do is to change the value of head to be the new node. So head refers now to the new node, And again, that assumes that the new node has been created, has been initialized, and that the reference of that new node is null. This node is now the first one because it's referred to by head, and it's also the last one because its next field is set to null. A very simple case. Now, if head is not null, means that head refers to a node, which means there is at least one node on the list. The list is not empty. So we're going to do the else part. And the else part, we create an external reference, which in this case we call it temp. And temp starts at the very beginning of the list. So temp has the same value of head or front. So if this is the list, temp starts right here, having the same value of the first node on the list. And then we're going to use a while loop to traverse the list until we find the last node. How do we find the last node? We had done this in the past, but let's review. The last node is a node that has its field called next equals to null. We're going to traverse the list as long as we are looking at a node that has a next that is not null. So we start right here. Well, the next field, the next reference of this node with value g is not null, it's another node. And what do? Well, then we move the value of temp. So temp, instead of being a reference to the first node, becomes a reference to the second node. And then we check for the condition. Is the next field of that node null? No, the answer is no. It refers to another node. So again, we advance temp, and now temp is referring to this node. And now when we do this test, we ask the question, is the next reference of this node temp.getNext, is that equal to null? Well, currently it is null. In the original list, this will be the last node, correct? What we want to do is the condition evaluates to false. We know where the last node is. We have temp referring to it. So now what we have to do is connect the new node, which has value s and refers to null, to the list. And we do that by simply utilizing this statement. And this statement says, okay, let's change the value of this next that we're looking at to be what? Well, to be value of this reference here. So this reference new node and this reference next from this node refer to the same node, which is now the last node. So if we review this list, we have the beginning very well marked by a reference called front. Every node refers to the next one. And now O refers to S, and S is the last node on the list. And the very last node has a reference next set to null. So we end up with a perfectly created linked list.